Welcome back to the DevBlog series for Bayside Games. In this series we're developing a game called Robots Can't Jump for iOS and Android. So, I don't know, in our last session we left off and we were busy adjusting the physics model of the game. There's still a whole lot we've got to do here. Let's start off with making a quick list of the things we need to look at. So what I'd like to do is to move the linear velocity clamp, which is this piece of code here, into the base actor class, because I think it might actually be useful to clamp the velocity of pretty much every rigid body that isn't used by an actor. So let's do that. That should be really quick. We don't even need these prints anymore because we know it's working now. This could actually be very useful for pretty much every actor. So the player class, if we go and look at its definition, is an actor object, so it's right from actor. So let's go look at actor. Okay, so there's a huge amount of stuff in here. An actor is very, very simply a wrapper for a rigid body with a couple of other things, and it also has things like animations and stuff like that you can do on it. So we'll look a little bit more at the structure of that later on. Right now we're only really interested in adding this linear velocity clamping, so we should be able to do that in the base actor update function. So let's just go and find that. There it is. Okay, so the base update function doesn't actually do a whole lot, which is good because it makes it easy for us to just paste this piece of code in here. So right now this is going to apply to every actor, and I think we can leave it that way. But if we actually wanted to just make it a little bit more flexible, what we could do is we could allow people to specify this constant for each actor. So what I'm going to do is I'm going to actually move that into the header, and we're going to turn that into a constant member variable. We'll just add it last on the list. So using my very, very simple version of Hungarian notation, we're going to call it mmax velocity length. And this constant is used to clamp the linear velocity of this actor's rigid body to the specified value. So very simple. And now we can add that to the constructor and we can give it a sort of a default. So if you look here, you'll see we initialize a whole bunch of stuff in the constructor, and if you remember the order, it comes right after the rigid body type. So that's not actually present here, which is fine. What we want to do is find the last member variable, so we get it in the right order. So if you look here, actually rigid body type is there, so it's right after rigid body type. So let's pop it in here. You can see we've already got a red line here because it wants us to add this variable because it's constant. So, if I recall correctly, the value of this was, let's just undo, so I can't remember, 0.5. So that was its value, very simple. So let's pop that back into the constructor. So 0.5. Now this is all fine and dandy. That means that all actors are going to be restrained to 0.5, but it's not flexible enough as far as I'm concerned. So let's go and have a closer look at the declaration of our constructor, which is how we construct all actors. Here it is. We only have the one constructor. And if you look closely, in the private section, these are all private member variables. You can see that by putting a mouse over here. See the little lock icon over there indicates that it's private. So we're not allowed to use these for the very simple reason that I don't generally want people placing actor objects into things like STL containers just ad hoc. I want to have a little bit more control over how that happens. So by having these constructors be private, that literally means you can't do that. You'll get compiler errors. So it's really just a very fancy and maybe a little bit heavy-handed way of forcing people to think about how they allocate actors. Like the general allocation model for an actor is pull a new memory block off the heap and that's your actor. The reason for that is because actor objects could potentially become very large. And in fact, they're pretty big already. So we don't really want people copying these things ad hoc, particularly on very low power platforms. You know, like the iOS generally is running on a fairly slow processor with a very small amount of memory compared to your average PC. So that's a bad thing to have these things copied around ad hoc. So anyway, going back to the main constructor, this is pretty much the only constructor we allow. If you look carefully, you'll see the last argument is a default argument, which you're allowed to have in C++. That means that people don't actually have to specify when they create an actor. So what we can do is we can actually add another default argument in. We'll just get rid of those. So if I just want to get the name right. The name was max velocity length. So I think that this is actually a very poorly named variable and we need to rename it. So I would call it mmax linear velocity length. That's a lot better. A much nicer description. I'll just rename this one too. And then we're going to use the same name in the constructor. just to keep everything consistent. So it's already there. You can get rid of the m because that's not the name of a memory variable. It will be assigned to. And the default value can be 0.5. So it's optional. Like people can, if they're creating new actors, specify this if they like, if they desperately want to change the maximum linear velocity clamping. And you know, we could go even further and allow that to be set at runtime, or, you know, just changed arbitrarily on the fly, but I don't think that will be necessary for now. So we'll leave it as that. See, we've got a lot of red lines here, so I suspect that the compiler is not going to be happy with the change we just made. So let's have a look and see why it's unhappy. Wow, okay. No instance of overloaded function actor matches the specified type. That's very interesting. Let's kind of have a slightly closer look. No, this all looks okay. So let's see, sometimes the IntelliSense stuff doesn't like having new things added and you need to actually compile. But we definitely do have a problem here because this is now the old name. So we'll just make it mmax. So just set it to be the old name. Alright, let's compile that quickly and see what happens. Okay, so we do have a couple of compiler errors. So the error, the prototype for RStuJ actors constructor does not match any R, of course. Okay, so let's go and have a closer look at the prototype. Of course, that's why it's happening. So we forgot to add the this little piece, this little argument into this one. No, take out the default because you don't have defaults in function definitions. And as you can see now, all the red lines are gone. So we should really have listened to the red lines and done a bit more work before we even got to the compilation stage. And this code should work unmodified. We're already creating actors in a bunch of places. So just by having a new default argument, nothing really needs to have that extra argument in. We can add it later on, but it should still compile correctly as it is here. And it's still going, so I'm just going to cancel it. Let's do it again. Okay, so that worked a lot better. So now let's just make sure that it still runs properly. I think I may actually be in the wrong profile here. I was just testing out the deployment earlier. Yep, so I'm just going to cancel that. That's not what I want to do. I want to go into x86 debug. It's just going to take a few seconds to compile. There we go, it's finished compiling and it's running, and let's go and have a look. Yep, everything seems okay. And as you can see, we're still jumping really high, but our linear velocity is being clamped, so that's good. Working great, alright. So I'm quite happy with that change, and I'm just going to submit that now. Okay, so that's submitted. So the next thing I want to do is to adjust the roll speed. So I'll just run the game and show you what I mean. I want to adjust this roll speed a little bit. So if you look closely here, the roll seems to start too slowly. Like it just doesn't feel good. It doesn't feel as powerful as it could be. Like this little robot can really move, and I want to give the player a really good experience. And the other thing that I want to do is change the boost ramp up speed because it's way too fast. Like if you fly down over here, you jump down, you see he actually seems to fly around and he bangs into things really easily, which is not really what I'm designing. I want to give the user a little bit more control than that. So it should be more of a controlled acceleration. So let's go and change those things. So the very first thing is we want to look at the roll, which is this composite input method roll. So this class has already been created. And as you can see, I use the same pattern everywhere. Wherever I apply a force, I usually have a constant. So in this case, the roll force is 30, which is a point A on the roll curve. So let's just go and have a quick look at how that is used before we sail in and change it. So when the left or right keys are down, it applies this roll force. So it's just not doing anything fancy with it actually. There is no curve on it. So the physics is giving us sort of a pseudo curve. So if we just decrease that slightly, let's see what it does. Okay, now it's even worse. So that was actually the wrong thing to do. What I wanted to do was increase it. That actually feels quite a bit better already. So I can jump. Okay, so this rolling is really working quite well. Yeah, it feels like I can move around really well here. So that's pretty good. We probably still need to polish that a little bit more. I'd say maybe make it 50 and then it'll feel good. So that's probably fine. Now the next thing I want to do is adjust the boost speed. So we'll go to the Composite Boost method. There we go. And this is purely for the PC version. We'll look at the iPhone version a little bit later today. But what I want to do is just adjust. This 300 is the force that's being applied. So it's applying a huge force at the end of the curve. So let's make that a little bit smaller and try that out. That's already beginning to feel a little bit more like how I'd want it to be. It's still much too fast though, because when you're thrusting upwards with a jet or some type of rocket motor, you don't just instantly jump into the air. It's a lot more gradual than that. So as you can see here, he's just going insanely fast. So we probably want to ramp that down even a little bit more, maybe to 150. Make it a little bit easier to control. And because we have the ability to infinitely boost, we can actually get quite a bit of control. So we want him to be able to just sort of control where he lands quite easily. He still feels like he's ramping up much too quickly. So if you had a little jet under you, you'd probably find that jet to be incredibly powerful and G-forces would be crazy. So let's try 100. At the same time, we don't want him to be too slow. So it's a bit of a balance that we have to strike here. We'll probably use similar values to these in the iPhone version, just driving them in a slightly different way because of the touch input, so we can lose a lot of things. That's actually feeling pretty good. It feels like when I'm falling, I can arrest my fall and come back up. But I'd say probably still too strong. So let's make it something like 70. We want to give the impression of quite a heavy robot with a powerful jet motor on him, so he'll have inertia. So that'll feel a bit more realistic. Because robots tend to be not very light. They tend to be quite heavy. That's looking a lot better. The other main problem that I can see here is that there seems to be sort of an acceleration that's happening. Might leave that for now, but this acceleration is not really too desirable. You don't want him to go flying off into space. Let's see, here's a nice long section where we can try it out. Okay, accelerating. Actually, the linear velocity clamp seems to help him quite a bit with that acceleration. It doesn't seem to get too insane. That's sort of closer to what I want. Whoa, it's powering down. Yep, I'm pretty happy with that. So we'll call that done for now. It's probably 90% of where I want it to be. So I'm just going to submit that